Part A, we want to find, we have these two vectors in space. We have them graphically represented here. A is the black arrow and B is the red arrow. So in the first step, we just want to find the angle between vector A and vector B. So what we're trying to find is what's this vector, or I'm sorry, this angle in here. And to do that, since we're in the dot product section, we want to use the dot product to find that. So we know by the first definition of dot product that A dot B is going to be the magnitude of A times the magnitude of B times the cosine of the angle between them. That angle is what we want in part A of this question. All right, so let's start on the right-hand side. That's an easier place to begin before we actually address the other definition of dot product here. So we want to first find what is the magnitude of A. So based on the values in A, what is its magnitude? 9. It's 1 plus 64 plus 16 is 81. Take the square root of that, and we get 9. So magnitude of A, we get 9. Okay, now we want to find the magnitude of B. This one's harder to do in your head, but it'll just be 19, right? So 1 plus 18 squared plus 36. So in that case, we get 19 is the magnitude of B. This other part we don't know yet. That's ultimately what we need to find, cosine theta AB. Now we need to work on the left-hand side, and this is where we use the definition we just saw for the dot product when we have those vectors in component form. So we were given A in component form and B in component form, so we can find that left-hand side. We want to multiply the like components and add them together. So in terms of the coefficients in I, the first part will be negative 1 times a positive 1. We add to that 8 times 18. And we add to that 4 times negative 6. Right, so again, a scalar, a scalar, a scalar. There's no i's, j's, or k's. I add this together, I get 119. So I can isolate that cosine term on my right-hand side by dividing through by 9 and by 19. So the last step, if I take the arc cosine to both sides, I can find the angle between A and B. It is going to be 45.9 degrees. Questions on finding the angle between the two vectors. So we did have to use this the kind of new definition we have for dot product. This one we did use the cosine definition, which generally we won't use that much in this class. But in this case, we did want to find the angle between those two vectors, so we did need that definition. All right, so part B, this is where we actually use the projection. How much of A is directed along B? So here, kind of graphically what we're doing, I'll use this pointing tool here. So we want to project A onto B. So it's tough to see in 3D, but we're making that kind of perpendicular line down to B, and we're going to be finding how much of A is along it. Probably the previous graphic is going to be better here. Right, so if we were looking at flat on, we want to know how much of A is directed along B. We're looking for the magnitude of this part of it as our first step. So I shall flip back, or I'll stay here for a minute. So the operation we need to know how much of A is directed along B is we're going to take our vector A and we're going to dot it with the direction of B, not the actual vector B. So A parallel as a scalar is A dotted with u hat B. A we were given U hat B we were not given, but we can find it because that's just going to be, if we take vector B and we normalize it, that's going to give us just the direction of B. B was I plus 18j minus 6k. And we found in the previous step what the magnitude of B was. We found that it was 19. So if we divide the value of B by its magnitude of 19, that result is the unit vector in the direction of B. So 1/19th I plus 18/19 j minus 6/19 k. Now I can take the dot product between these two vectors, which is different than what I did in part A. It will be -1 times the I component of U hat B, 1/19. I add to that 8 times 18/19. And I add to that 4 times -6/19. Adding up all these numbers, I get 6.26 when I go through the arithmetic here. And what I keep in mind or pay attention to, again, is units are always important. When I take the dot product between two vectors, I'm going to multiply their units together. In this case, though, I have units on A. It was given to us in newtons. And the unit vector is always unitless. So the unit is just going to be newtons times blank, basically, which will give us back newtons. Right, so that is the amount of A projected onto B, or the amount of A in the direction of B, 6.26 newtons. Right, in the third part, I want to take this parallel component that I just found. I found its magnitude. But in part C, I want to express it as a vector. So not just the magnitude of it, but actually the direction and the magnitude of it. So again, I'm still describing this vector, but now I want the components of it, not just its magnitude. So I can look at line 2 here, and I can find the component form of a parallel. Now this is a vector. This is going to be the magnitude that I just found, multiplied by its direction. Again, we know that A parallel shares its direction with B. That was kind of the whole point of this. How much of A was along B? 6.26, that's my scalar. And now I multiply it by U hat B, which I found above. So it's just a scalar times a vector. So I'm going to basically distribute this 6.26 into the I, j, k components of U hat. So this is going to give me 6.26 times 1/19. As a decimal, that will be 0.33 I hat plus 6.26 times 18/19 will be 5.93 j, and 6.26 times -6/19, -1.98 k. I'm multiplying, so I have to multiply the units. This was in newtons. This was unitless, so this too is going to be measured in newtons. Last step, we want the vector form of now the perpendicular component. We just covered the parallel. We now want vector of perpendicular. Going back to some of these rules, how can we find the vector? We're finding this piece now in vector form. How can we most easily find this value? The vector form of the perpendicular component. We don't know a perpendicular. We found a parallel in the previous step. We were given A, so the only thing we wouldn't know is A perpendicular. So right, this will be A minus A parallel. Again, A is -1I plus 8j plus 4k. A parallel we just found, so we just have to subtract the like terms to find A perpendicular as a vector. Right, so we're going to take -1 minus 0.33, and that will give us a -1.33. 8 minus 5.93 will give us 2.07j. And 4 minus negative 1.98, which will be 4 plus 1.98, leaves us 5.98 K. Again, for units, A was given to us in newtons. We're subtracting A parallel, which also is in newtons. So this as well is going to be measured in newtons.